So this event is brought to you by DataTalks Club, which is a community of people who love data. We have weekly events, and this event is one of them. We actually have two types of weekly events, and you can learn more if you go to our website and find the events page there. So today we have a webinar, which is an event that we have every Tuesday. It's more technical. We have a presentation and then Q&A at the end. And we have also podcasts on Friday, where it's less technical. It's more like a discussion. So this week, we will talk about GitOps for machine learning right now. And then on Friday, we will talk about building and growing technical online communities. And yeah, so if you want to find out more about the events we have, go to our website. There are other ways you can stay up to date about our events. So one thing you can do is subscribe to our email newsletter. Then you can join our Slack, and then finally you can subscribe to our YouTube channel. And the last thing today for questions, we will use Slido. So the link is pinned in the live chat. So just click on it and ask any question during the talk, and then at the end of the talk we will have the Q&A section where we will cover the questions. So that is all I have to say. And yeah, Alex, floor is yours.
Great. Can you see my screen okay?
Yes.
Brilliant. Well, thank you very much for inviting me to speak today. I'm going to talk about deploying machine learning projects into production environments, in particular, the continuous deployment of machine learning projects through automation techniques. I'm going to touch on why machine learning projects can be hard to deploy at times and how automation tools like Bodywork can help out with this. In particular, how a particular pattern known as GitOps, which is embedded in Bodyworks, can be useful for getting our systems into production. And then once we finish with all the technical stuff, I'll give a few case studies and demos of this pattern in operation. A bit about me before we get going. I'm the co-founder of Bodywork Machine Learning, the creators of Bodywork. Before this, I've worked a number of places across London. Perhaps most relevantly, I used to work in MLOps for Oracle, deploying their machine learning models across their cloud apps division. So that's pipelines at scale. And I've built machine learning teams for various startups in London. And before that, I used to work in financial services as a quant analyst, which is where I went after I left academia. Just to set some expectations, I am not a software engineer. This is not going to be a lecture on DevOps best practices for data scientists and machine learning engineers. What I'm going to try and communicate are all the useful bits that I have learned, and I've had the privilege of working with some brilliant engineers in my time. And I want to get across the bits that are really useful and what matters to us as machine learning engineers and data scientists. So what is continuous deployment? Well, most of us have probably heard about CICD pipelines, in which case continuous deployment is the CD in CICD. If you don't know what a CICD pipeline is, then don't worry, because I'm going to cover that in the next few slides. So continuous integration, the first part. This is a schematic representation of a continuous integration pipeline that I've set up many times in the past, and I'll just take us through that here and try to put a machine learning data science spin on it. So we start on our local machines. We're working on a branch to maybe add a new feature to an existing system. Let's say you want to add a new feature into a model that you're training, so you're extending feature engineering and the training regime to be able to take this new parameter. You've finished your work, you've committed changes, and then you push your branch to a remote Git server. Let's say it's called GitHub. And at that particular point, your continuous integration service, which in this case is provided by service called Circle CI, which I've used many times in the past, but could easily be a Jenkins server or from Travis or GitHub Actions, are very good as well. That will start off some automated tests. It will run all your unit tests, all your integration tests, and then that will report back to GitHub if they've passed or not. At the same time as you submit your pull request, you should ask your peers to review your code as well, just in case you've missed something. Maybe they spotted a problem with the changes that you've made that you haven't seen. But in any case, you should get that peer review at the same time. And then once you get the thumbs up from your peers, and once your continuous integration provider has said that your tests have passed, then you're ready to merge your code to the main branch of your project's repository. And what continuous integration allows you to do is it gives you a certain amount of quality control on the code that's being pushed at any one given point in time. And it allows you to scale to multiple people working on the same project. Just a little aside on what unit tests and testing looks like for machine learning systems. I've put here a few examples of tests that I've written in the past. A good example is you write a test that makes sure that your model will fail gracefully if it sees a category it hasn't seen before, or an outlier on sort of real world behaviors that you want your system to embody so that it doesn't raise an exception when it's being used in production. Similarly, when it comes to integration tests, let's say you're spinning up a microservice for exposing a REST API, and for scoring data with a machine learning model, you want to make sure that that contract between the API and the user is always maintained, is never broken as new code and changes are pushed to the repo. Now, I'm skimming across the surface of testing here, but there's a very, very good blog post on effective testing for machine learning systems, which I'll point you to if you want to go into this in a bit more depth. But onto the continuous deployment part. So we've merged our code into the main branch. Now what? Well, in a lot of the pipelines that I've built in the past, my continuous integration service can now run something. It can do something now with this new state of the main branch. And that something is what we're going to talk about next. And it really depends on what sort of a system you're deploying. You may just want to run your training regime and then push the trained model into a cloud object storage for other people to use it downstream. You may be a little bit more rigorous in how you manage that and push to a dedicated model registry like you have in MLflow. You may have an MLflow server hanging around. You push the latest model to the registry, and then anyone downstream who wants to use this model, maybe for scoring data in batch, maybe for embedding within the rest of your systems, but they can take the latest version from the registry. Maybe you want to deploy an entire system from this point onwards. So you want to containerize your machine learning service or application, then you're going to push that container onto the cloud somewhere like Elastic Beanstalk on AWS, maybe Elastic Container Service, some type of container orchestration platform, or maybe even a Lambda service backed by a container, which you can now do on AWS. Or maybe you're going to push it to Kubernetes. And that's cloud agnostic, runs locally, runs many vendors these days, and is a different way of orchestrating containers. And also my favorite way of orchestrating containers. So I'm going to just spend a minute just telling you why. I personally think that Kubernetes has all the resources embedded within it for building a fairly functional machine learning operations platform. It has a concept of jobs. You can run jobs on a schedule, like cron jobs. You can deploy services, and the networking between services is very, very easy when you know how. Likewise, resilience and horizontal scaling are built in from scratch with Kubernetes. So it makes for it's relatively easy to build resilient systems when you know how to do it. Of course, if you know how to do it, it's quite loaded because there's quite a steep learning curve associated with using Kubernetes. And I think it's a fairly moot point to expect all machine learning engineers and data scientists to go up that learning curve. And that's where tools like Bodywork come in, because they help you bridge that gap. If you're interested in how to deploy machine learning systems on Kubernetes from the bottom up, then there's a blog post written by me, which is quite popular and I think has a lot of detail, and we'll walk you through that whole process. So that's CICD. It's about going from changes on our local machines that we do to extend our products and untrain our models, how we implement some form of quality assurance, how we merge it into a central code base, and then methods for deploying it into our systems. But in general, why do people say that machine learning projects are hard to deploy? I think this is demonstrated quite well with a very simple pipeline that you have here, one that I've deployed myself several times. Start off in the top left and you're training a model. Maybe you're doing this on your local machine. Maybe you're doing this after you've pushed your code to your main branch. And then you're taking that trained model and you're containerizing it. You build that container. Once again, that could be done locally. You could be doing this all manually, or you're doing this as part on your continuous integration service. You push that image to a registry on AWS, say, or Docker Hub if you're happy to have them public. And then you need to trigger a deployment on Kubernetes in order to pull that image and roll out your system. Why is this so hard? Well, there are multiple points of failure, which is never a good place to be. It requires more than the basic understanding of Docker and Linux to do this, especially if you're going to be reliant on Python libraries that are going to be building binaries, or that you need any other supporting libraries to go with it. You need to understand your container orchestration platform very well. So you need to have experience of Kubernetes, but if you're not using Kubernetes, you have to understand how AWS works or GCP works or whatever platform. They all have their idiosyncrasies, and you need to gain experience with these. This pattern doesn't scale easily either. I mean, if you're responsible for 3, 4, 5 models, or go into double figures, then you've got to be maintaining all of these deployments, all of these pipelines. And then that becomes quite a big responsibility. And this is not machine learning, this is DevOps. And I don't know about you, but that's not what I signed up to do. So how can we make this easier? Well, we designed Bodywork to tackle these problems head on. And it picks up at the moment you merge your latest code base, you can then hand off to Bodywork and it will take care of everything in order to get it onto Kubernetes. So you don't need to know anything about containerization. You don't need to know anything about Kubernetes. You can hand off that responsibility to Bodywork. And what's actually Bodywork actually doing for you? I talked about automation as a means of achieving continuous deployment, and that's all that Bodywork is doing. It's automating all those steps that you would otherwise have to do manually, so that you don't need to do them manually. You don't need to write a script for every project that you want to put together. You can make it repeatable via automation. Deployment automation, that's at the core of what Bodywork does. So one of the problems that we wanted to solve is how can we do away with this build and push, deploy sort of feed forward pipeline that we sketched out earlier on? Because I don't, my experience when we've tried to hand off the responsibility for continuous deployment pipelines to data scientists is that it's fine until they go wrong, and then you need to go in and sort it all out. So we just wanted to remove that. So we came up with a generic container that can run Python code. We install it, Bodywork, on this container. We install Git. We install a whole bunch of other build tools that you may need for installing libraries that you want. And then if you want to deploy your machine learning project using Bodywork, you configure one-off time to Kubernetes to spin up a workflow controller, spin up one of our containers on the cluster, and then Bodywork containers will essentially do a Git clone on your repository and to pull your code into a container that's already on the cluster. then analyzes your repository, it sees what different stages or different components you have, and then it makes a decision about how it's going to deploy them. So if you need to run, say, one batch stage for training a model, and then you need to start up a service that will use the model that comes out of that service, the workflow controller will realize that you've got a very simple DAG there and fire up a separate container for running the training job, and then fire up a separate container or containers for spinning up the service. So the idea is that we've done away with this feed forward pipeline by basically asking a pre-built container that's sitting on your cluster to do a git clone from your repository, analyze your project, and then work out how best to deploy it. So baked into this is a concept of workflows. So you break your deployment into a set of different steps that can follow one after the other, and each step can run multiple stages concurrently. It's all a bit abstract, but it does allow you to come up with some weird and wonderful service topologies and run with quite a high level of concurrency. So let's bring this back into something that's a little bit more tangible. Let's say you've got a machine learning pipeline that will, first of all, train a model, and after it's trained the model, it'll serve the model. What do you actually need to do in order to deploy this using Bodywork? Well, you obviously have to have your project on Git. Currently, we only support GitHub, but we'll support all providers in the future. And you need to structure it in a particular way. And we feel that it's relatively light touch. The only real piece of work that you need to do is to make sure that each stage has an executable Python module associated with it. And then each stage also has its own directory that has all the files required. And in this example here, where you've got train and serve, which we'll demonstrate in operation a bit later on, you've got one directory for training a model, and you include your Python executable that will run your training code. You've got a file that has all the requirements that you need for running this module, because it will install those requirements dynamically for you, and in a bit of lightweight config. Similarly, for the serve model stage, you have to supply it with a Python executable for starting your server, in this case, starting a Flask app. Requirements and a bit of config, and then there's a bit of config for the whole workflow, which in this case is basically saying, please run stage 1 first and then run stage 2 afterwards. So once you get that configured, you use Bodywork to configure Kubernetes. Bodywork is essentially distributed as a Python package that you install locally, and it communicates with your Kubernetes cluster in order to get Kubernetes to perform the deployment for you. So you use Bodywork, you basically configure Kubernetes to run Bodywork. It starts Bodywork. Bodywork will clone your project into a pre-built container, gets analyzed, and it works out how to deploy it. So it'll run the training job, start up the server, and then expose the service that's behind that. So if we now take a step back, let's have a think about what CICD looks like now. In this particular instance, you've still got all your the continuous integration sort of quality assurance part here, but your concern as a machine learning engineer or a data scientist now stops at this part here, because once you've configured Bodywork to go to that repository, maybe on a continuous basis, you don't need to do anything else. Bodywork will just go to your repository every time it needs to rerun a workflow and pick up the latest version that you've got there. GitOps. We've essentially arrived at GitOps now. That's why GitOps is in the title of this presentation. I didn't start by talking and explaining what GitOps was, because that would be a bit dishonest, because I didn't set out to build a GitOps first machine learning deployment platform. What really happened was that we were tackling these problems with machine learning deployment head on. And then towards the end of the first version, I managed to pick up this book by chance, really, and realized that we'd reinvented GitOps without knowing it. But that when you read a bit more about GitOps and what it seeks to do, it's a really good way for deploying things, especially when it comes to the cloud, because it means that you can do away with a lot of these build pipelines. The core of of GitOps, the core idea is that everything you need for your infrastructure, for your environment, and for the application as well, it is stored within a Git repository that is used as a target for deployment. So eventually your system will eventually always try to match that state that's held in your Git repository. Likewise, if you ever want to roll back a version, you roll, to create another branch or whatever, the system will eventually converge to that state, and that's essentially what Bodywork is doing. And a lot of the GitOps systems that you see out there, and including Bodywork, one of the patterns that they use is just polling that repository for changes, and if there's a change, then it deploys the differences into the cluster. Okay, so let's have a look at this in action. I'm going to show some demos now. All of these are available in our Git repository. If you want to try them out yourself, they're available as template projects that you can clone and then modify for your own specific use cases. So we're going to start with very simple demo of just serving a model. So we've got a pre-trained model, and we're going to create a microservice with a REST API and deploy it onto a Kubernetes cluster using Bodywork. So the project structure that you need on Git looks a little bit like this. You've got the Bodywork config file, and you've got a directory that has everything you need for your scoring service. You've got the executable with the Flask app. You've got a little bit of config, requirements, and in this particular instance, we've got the model as well, just because it makes life easy. And if I'm successful in swapping my screen over, you should be able to see the repo that we have. Brilliant. Okay, so the config for the stage is fairly simple. What you really need to tell Bodywork is that it's going to be a service stage, not a batch stage. So it will actually run it as a deployment and expose it as a service. Which file is the executable Python module that you want it to run, some requests for resources to make from the cluster, and then a few service-specific config parameters as well. How long to wait for the service to be up and running without any errors before it flags it with a thumbs up. How many replicas of the service to make. So if you want to scale horizontally, all you need to do is change this number, say from 2 to 10, then you get 10 pods backing the service that you can adapt to changes in traffic. You give it port that the service is exposed on, and you can choose whether or not to expose the service to the outside world, because you may just want to expose the service to other services within the cluster. Requirements file is much like any other Python requirements file. This is everything you need for running the service. And you've also got the Python executable, and I won't go through this in depth. Safe to say that it's just a Flask app with an endpoint that receives an instance of data as JSON, converts it into a NumPy array, passes it to a scikit-learn model, retrieves the prediction, and then returns a prediction as another piece of JSON. The most important part here is probably what happens when you execute the module, which is you load the model and you start the service. And you've got a very simple high-level config file as well, where you specify your DAG, where in this particular instance, the DAG is really simple because it's just one step and one stage. Okay, so let's take a look at this in action. Now, because it's a command line tool, doesn't really give much in the way of a demo. So what you have here is a terminal. In the bottom half, you've got the commands, and we're going to stream the logs to this machine. And in the top half, you've got all the Kubernetes resources in this particular namespace and their state as the deployment rolls out. Let's take a look at this in action. So first thing we do is that we set up a Kubernetes namespace for our project. It's a bit like a dedicated network. Then we run the workflow. So we're cloning the Git directly from Git. Nothing's being pushed into our workflow controller. The workflow controller has realized that you just want to deploy a service. So it's spinning up a service. We wanted only 2 replicas for this service. So you can probably just about see there that there are 2 pods starting up. We asked it to wait for 30 seconds before we gave it the thumbs up. So once we get to 30 seconds, you should see that there's been no errors, and then the service will become live. Yep, the workflow is finished running. We've got all the logs from the pod there. So now we can get the details of that service. We should be able to interact with it. In this instance, we're exposing it to the outside world, so we can get our prediction result nice and easily. Now, you can put that entire process on a schedule as well with one command. So you can ask Bodywork to rerun this particular job every hour, every 15 minutes, every evening, whatever is appropriate for your project. And then each time it needs to run, it'll go back to your Git repository, pull the latest state from the particular branch that you're deploying from, and deploy that. So if there have been any changes in the interim, they will be automatically picked up in the next time the workflow is executed. So it's very easy to extend this particular paradigm. In this instance, let's put a batch stage at the beginning in order to train a model. And rather than bundle the model together with the service stage, let's put it all into cloud storage and get the service stage to pick up the trained model from cloud storage in order to redeploy it. In this particular instance, the project is extended with an extra directory that includes a train model file, as well as a serve model executables, and then together you can run this pipeline. It's much the same way as we did before. We set up a namespace that's dedicated to this particular project. And then we trigger the workflow. Although this time, the first thing you should see is a batch job crop up in our set of resources up on the top, and that will be downloading some data into the container. It'll be training a model, and then it'll be pushing that model onto S3. If you want to look at the details of what's actually going on there, then you just need to head over to our repository on GitHub. So it's completed that first batch stage, so it's moving on to the deployment stage now. Just like last time, it's going to wait for 30 seconds to pass before it declares that the service is okay and is operational. If it wasn't, if there was a problem and you already had a deployment there, you'd get an automatic rollback of that deployment. So we exploit all of the wonderful properties of Kubernetes to make sure that all the deployments happen on a rolling basis and that there's never any downtime when any of these actions and events are happening on the cluster. So there we are, it's up and running, the service has been exposed, so we can get the details of the service that we've got there, and then we can test it, we can curl into that service and get a result, just like we did last time. And once again, we can put this pipeline to run on a schedule as well. It's not the only, setting up microservices and REST APIs isn't the only thing you can do with Bodywork. If you want to define jobs using Jupyter notebooks, you can do that. We've got an example in our repository of how you can work with Jupyter to run jobs using Jupyter notebooks. Every time they run, you can save the state of that notebook, push that saved notebook onto S3, so you can retrieve it at a later date, and you can build whole pipelines of and your projects, and you can deploy them in this way. Likewise, because Bodywork is quite generic, it really is just an automation tool on top of Kubernetes that runs batch jobs and spins up services. You don't have to just run Flask-based services. If you want to serve up a Plotly dashboard, if you want to set up a Plotly dashboard and a REST service, let's say you want a dashboard for explainability, you can do that as well. It's really just helping you to deploy your project. It's not trying to tell you that you should go about deploying machine learning systems in a particular way. Here's an example of a Plotly dashboard that we have in this particular case study that's up on our repository. The key message here is that you can solve a lot of problems that we encounter in machine learning deployment by using GitOps-like techniques, and certainly by using deployment automation for things like Kubernetes. That kind of brings us to the end.
Okay, thanks. Just to maybe I missed that part, just to understand what it's doing. So it pulls the Python files, like all the project files, right, and it puts them in Docker, right? So because on Kubernetes, to deploy just something on Kubernetes, you actually need to package things in a container, right? So it does that under the hood, you don't see this as a user, right?
So yeah, so what it does is, if you look at this example, let's say you got the two stages, the train, model, batch job, and the service. All the code sits on GitHub, and when you trigger the workflow, what Bodywork does is that it pulls your entire project into a workflow controller, which is a container that we host on Docker Hub. It'll then clone your Git repo into that to work out how many stages there are. And then it works a little bit like Airflow Lite or like Argo workflows. But rather than doing any building of Docker image, what it does is it takes the requirements for every given stage and installs them into that Docker image that we've had pre-built, and then runs the Python executable.
Okay. And this is do you actually need to push, you have this image, do you need to push it somewhere to some?
Nope.
And how do you roll back then? I was I was thinking when you mentioned during one of the demos, you mentioned rollbacks, and I thought, okay, if everything is packaged in a container, then probably the deployment would just pull a different container, right, with the previous version. But
so the containers running the previous version never get wound down unless the incoming deployment is deemed to be successful.
Okay.
So they'll only be shut down once the incoming deployment, is passed.
Mm-hmm.
But in any case, if you detect the problem, let's say you get an alert that says something's gone wrong, you need to intervene. What you can essentially do is move back to a previous tag in Git, and then it can deploy directly from that.
Mm-hmm. Okay.
That's one of the key advantages of using GitOps-based techniques, is that your version control for your deployed state, or rather the state of your deployment, is closely matches the version control.
Okay, that's clear. And one of the questions was in slide, how do you roll backs? And I think we just covered that. Yeah, so we have 4 more questions. I just want to remind, if you want to ask a question, there is a link in the live chat. It's pinned, so just click on that and you can ask Alex any question. So the next question that we have is, what if we need something more custom than a Python file and requirements.txt? How much freedom we have, and can we use Docker for that?
Yeah, so you can specify your own Docker image. So in the bodywork .ini file, you essentially point it to the Docker image that you want to use, your generic container. So if you want to add extra binaries in that, for whatever it is that you're doing, or custom binaries, you can add them there. So you can customize the Docker image. You're not forced to use the one we have. So you can put it on your own image as well, your own registry, sorry.
Yeah, I can imagine situations where you need to, I don't know, maybe build your own binary of some library that is not yet on this Python repo, right, with projects.
That's right. So if you want to go off Pipey, you can create your own custom repository without a problem. Your own custom image, sorry, and put it in your own registry. We support that.
Yeah, I to be honest, I don't remember if you showed how the Python file looks like, how it like the one that you had in within each project. Yeah, like this, for example, train model or.
Yeah. So I mean, if we go back to the train and serve pipeline, because I think it's a fairly good example of a batch job and a service stage. So if we go into the train model stage, then the Python module, I mean, it's fairly simple. The key part here is that if you were to run it, the idea of taking a step back now is that if you're on your local machine and you do Python train model.py, just execute the module, that's essentially what's going on the cluster. So you need to have the executable component down here, and then it just works through it as you might expect it to. For a service stage, it's much the same, but the difference between service stage and the batch job is that service stage is long running process. So it starts a Flask server here after it loads a few things into memory. And then because you mark it as a service stage and not as a batch stage in the config file, it will manage it like a long running service, and it will also expose your chosen port to the outside world. So it's essentially using different Kubernetes resources. It's configuring it differently for Kubernetes.
Okay, and it doesn't, as I understood, it doesn't matter whether it's running Flask or some other web service, right?
No, that's right. A lot of the machine learning deployment solutions out there kind of pick, in order to make the process really easy, pick one particular server and one particular API format. And we didn't want to do that. We wanted to make a deployment automation tool, but leave the flexibility to customize that service in the hands of the machine learning engineer, largely based on personal experiences where I'm working in a team with other software engineers that are going to be using the service, and they usually tell me what the contract is going to be, not the other way around. So I think you need that flexibility, or you may want to loop in monitoring and custom logging or whatever. I think you need that flexibility, and it gives you the flexibility to run other long running processes like dashboards or whatever else that might come to mind.
Okay, thank you. Then the next question we have is, what are the advantages over AWS SageMaker?
Well, AWS SageMaker, in my limited experience, still has that feed forward build, push, deploy. It just automates it for you. So I don't think it does away with the problem. It just makes your life a bit easier. You still have that particular feed forward pipeline. You're also tied to AWS as well. You may not want to be tied to AWS. And for me personally, I like the fact that because you're using Kubernetes, I can spin up a local cluster, say on Minikube, and test my system end to end. Whereas I've never been totally sure how you test something on AWS if you want to deploy a service. It's quite hard to do. So you get that assurance that your system in the cloud is running exactly as it is on your local machine, which I find quite useful. Then again, I'm a control freak, so I would say that.
Just a side note, I think recently, or I don't know how recently, but in SageMaker now you can test things with Docker Compose. Like it would speed up a deployment locally that you can test. But I have no idea how it actually works, because it's not really transparent. You just do something in Python code, and then under the hood it does something, and then you can test. But Like, of course, you need to go into the source code to see what's going on there.
Yeah, I mean, these things are powerful and they work very well. I'm not going to sit here and claim that they don't, but you usually have to spend a lot of time working, to devote a lot of time to working, getting them to work as you want them to. And they change very quickly. You end up becoming a specialist in AWS SageMaker.
So, do you see Bodywork being deployed in a research environment? Any use cases pop up in your head?
Yeah, definitely. So, I mean, there's research in machine learning and there's research in academia more broadly. I mean, quite a lot of people who run experiments need to run batch jobs, and they need to run to process the results of their experiments if they're experimentalists, or just because automation is usually the way to improve your productivity. So absolutely, this isn't just for engineers. This is for anyone that needs to automate stuff in the world of machine learning and Python more broadly.
Can these executable Python scripts files have some external parameters? For example, like, and this is, I should be sharing this the screen to make it easier. So this says myscript.py minus minus param1 minus minus param2.
The best way to pass parameters into your Python environment is via secrets. So one of the things you can do with Bodywork that we put in place is the ability to inject environment variables into containers. We envisage that mechanism to be used for credentials. So let's say, for example, you want to interact with AWS, you need to give it your AWS credentials, and that's done using Kubernetes secrets. We built a little, an API for that to make life really easy, and you can inject credentials into your containers in that way. But they're not meant to be parameterized per se.
And yeah, so we have a related question from live chat. Can these executable Python scripts have parameters? So this is a popular question, I guess. So is this like, can we use like environment variables like we would do in?
Yeah, that's basically how it works.
Okay.
But bear in mind, this system needs to, it's been designed to be autonomous on the cluster. So whatever, it's, in my opinion, it's probably a better way that it retrieves these parameters from somewhere else external to the system. Even in the lowest common denominator is that they sit on a file on in blob storage, or they sit in a database is a far better way to achieve these things. But you can inject them in by other means if you need to.
Or probably just keeping them in the config file is already good enough, right?
That's yes, another way. Absolutely.
And, I noticed you love ini files, not YAML. Like I think usually like now, right now, the tendency, like when it comes to config files, usually there's preference for YAML files. Like you would see YAML files everywhere. Yet you decided to go with ini files, with like the plain, I think it's config like package that is built in Python, right? So why did you decide to do that?
I don't think it was a really conscious decision over A versus B, really. I mean, one of the core design principles of Bodywork is that we wanted to try and do as much as possible with a Python standard library rather than bring in lots of external dependencies, so that it's as compact and as lightweight and easy to operate with in an enterprise environment. Obviously, if you're going to deal with YAML, actually, you have to bring in quite a lot. So I just didn't see the need. You could do everything you needed with ini fairly simply. And you say YAML. I mean, YAML is very powerful, but I spent so much time in YAML hell when I was operating with MLOps at Oracle that maybe I just developed a phobia for it. I don't know.
Okay, yeah, ini files are certainly a lot simpler. Well, of course, they're less flexible, but maybe you don't always need that flexibility.
We wanted to minimize the config options, really just to the bare bones, because I think like I alluded to, what we're really built here is a layer over the top of Kubernetes. The idea being that it abstracts just enough so that you don't really need to understand what's going on. If you're, competent at Kubernetes, you can write the manifest yourself. You don't need any of this stuff. The idea is that this is just helping you scale. This is just making your life easier so that when you go from project A to B to C to D, you're not continually setting up these, CD pipelines and writing these manifests, because it becomes really tedious and it's hard to debug. And I could go on. YAML, it becomes painful.
Mm-hmm. And yeah, we don't have any more questions in Slido. Maybe last one from me. Why Bodywork? Like why the name? Like, does it mean anything?
No, I think we were talking earlier on. I don't like cliches, and I thought to myself, it's a framework of some sort. And I thought, I can't call it framework. Everything's a framework. And I thought, bodywork, yeah, like the bodywork of a car, because all the hard work, the chassis, the engine, that's your scikit-learn or your PyTorch and Python and everything else. All we're really doing is putting a bit of bodywork around all this other stuff so you can get it into production easier.
Nice.
Hence bodywork.
Okay.
I'm not sure it works, but at least it's not ML framework 101.
And in the bodywork world, containers are cylinders, not boxes. Okay. Well, so we have another one from Kostas. Is there any option to stop the ML pipeline if, for example, the training has no data?
Yes. So the easiest way to do that is to make sure that your executable will exit with a non-zero exit code, then it will terminate the pipeline.
Okay. So basically, like whatever happens, like something, if there is an exception, some exceptional station, then you just exit with whatever code you want, and then it will say, okay, it's not zero, something is wrong, terminate, right?
That's right. If there's a zero exit code, the pipeline continues. If it's a non-zero exit code, it stops.
Okay, I guess that's all for today. Thanks a lot for joining us, for
Thank you very much for having me and inviting me.
Yes, and yeah, so I will probably will ask you to send me the slides and any link you want to include in the description, and I will just put everything in the video in the stream that we have. And then later, if you want to get the slides, you can just go to the description and download it from there. Thanks.
Brilliant. My pleasure. Thank
Yeah.
you very much. Have a good evening.
You too.